And welcome to my channel. So here today we are going to be looking at the momentum and ballistic pendulums. So what are they? So under this one we might have a pendulum like this. We might have the pendulum like this. Then we have a bullet. So in the first scenario we have the bullet, it enters. In the second scenario the bullet passes through. So how are you supposed to calculate this? So let's begin with this question. We have the ballistic pendulum. A pendulum is used to measure the velocity of bullets. A bullet of mass 60 grams is shot into a ballistic pendulum of mass 3 kg and lodges in it. The composite mass rises to a height of 1.5 meters above the equilibrium point of the pendulum. Finds the velocity of the bullet. So we are told that the bullet lodges in now to a height of 1.5 meters. So from here up to here we have 1.5 meters like that. Find the velocity of the bullet. So it lodges in, meaning to say it sticks like that. So how do we calculate the mass of such a thing? So firstly we need to know one thing. We are dealing with momentum. We know that momentum is conserved, so the summation of the initial momentum, P is momentum, should be equal to the summation of the final momentum. Now in this case, what are we going to be looking at? We have our M1, which is the mass of the bullet times its velocity. We know that momentum is equal to mass times the velocity, so should be equal to, we add plus the M2, which is for the pendulum. Let me call it the mass of B to be the mass of the bullet, plus the mass of the pendulum to be the mass P, like that. Then we have the velocity number 2, like that. Should be equal to, we are going to have add again, so summation the momentum M of the bullet times the velocity of the bullet. So let's be careful here. They form one mass, therefore it is inelastic collision. So we are going to say M1 plus our M2, like that, then times the velocity final, like that. So this is how we M1 times M2, because they form one mass at the ends there. Now what we are going to do is our mass of the bullet, just get, if it is in grams, just get the 60 grams, divide it by 1000 grams times 1 kg. This is the chain link. So when you do your calculation, it will give you 0.06. So we have 0.06 kg times the velocity of the bullet is unknown. So we have the velocity number 1 plus the mass of the pendulum is 3 kg. So we say 3 kg times the velocity. The velocity of this is, at the beginning it wasn't moving before the bullet was shot. So we are going to say times a 0 should be equal to our mass number 1, the mass of the bullet, mass of the pendulum. So in your working you can show what MB means, mass of the bullet. Then MP is the mass of pendulum. So our mass of the bullet, which should be equal to 0.06 kg. Let's move this a bit. 0.06 kg plus the mass of the pendulum 3 kg times the velocity final, which is unknown. So we have 0.06 V1 should be equal to, kg. V1 should be equal to 0.06 plus 3, it will be 3.06 kg. Then we have the velocity final, like that. So we are going to divide Okay, so this is our velocity of the bullet if we divide our 0.06, but yeah, so 0.06, 0.06, so that we have our 3.06 divided by 0.06. we are going to have our V1 should be equal to 51 velocity final, like that. So this is our velocity of the bullet. So you can include in your working to say V1 is equal to velocity of bullet. So after you have done that, what we are going to do is that we know that this has moved. We know that this has moved 1.5 meters. Now this movement is again in potential energy. So we are going to say now this potential energy is as a result of how the bullet was moving. So since the bullet was moving, it struck this and it caused it to go up. Since it caused it to go up, it means to say there is an increase in the vertical height. This vertical height is the potential energy. We know that as long as you have a gain in height, that's the potential energy. Now this potential energy came from kinetic energy. So we can say by conservation of energy, kinetic energy is equal to potential energy, which should be equal to, we are going to say our kinetic energy, which is the kinetic energy of the system, which is the mass of the composite thing, not just the mass of the pendulum alone. No, the mass of the bullet plus the mass of the bullets together with the bob. So this whole thing is the one that we are calculating for. So we have them according to the kinetic energy. Kinetic energy is equal to half m. Now in this case it will be big letter M because they are combined, m. Then we have the V squared should be equal to the potential energy, which is our m. Also it is the whole thing that goes up, mg times its gain in height. So this m is common, so we divide the m on both sides so that we have half V squared should be equal to gh, so that we have V squared should be equal to 2 by g, it will be 2gh. So the velocity, now this is the velocity of the system. What have I put here? So this is the final velocity of the system. You have used the mass of the system, so this should be the velocity of the system, not the bullet. So we are going to have this and this cancel, so Vf is equal to the square root of 2 times g times the height. So this gives us 2 times 9.8 times the height 1.5. This gives us the root of our 2 times 9.8 times our 1.5. It gives us 29.4, like that. So we have our Vf, the square root, our Vf is equal to the square root of 29, gives us a 5.422 meters per second. So this is the velocity of the system. So it moved with a velocity of 1.5 as it was moving up, 5.422. So with that said, we have calculated this Vf. So we are going to come here, take this equation and just replace to calculate the mass of the bullet. So we are going to have our V1 should be equal to 51 times the final velocity, which is 5.42, So when we multiply it by our 51, we are going to get a 276.53 meters per second as our velocity. Therefore, velocity of bullets should be equal to 276.53 meters per second, like that. So that is how we calculate the velocity of the bullet as required. Let's look at this other question. If it goes through, what are you supposed to do? So we have a bullet of mass 1.5, 15 grams, traveling at a speed of 6,000 meters per second, strikes a block of mass 3 kg, which is suspended by a string of length 4 meters. The bullet goes through the block in a very short time, and the center of mass of the block is found to rise a vertical distance of 10 centimeters as shown in the figure below. What was the speed of the bullet just after it emerged from the block? So what we have is, if you look at this, this will be treated as if it's elastic collision because it is no longer inside. So we know that the momentum is conserved. So what are we going to have? So we are going to have our m of the bullet times the velocity, number 1, plus the mass of the pendulum times its initial velocity should be equal to the final velocity of the bullet. So let's just name v1 is equal to velocity of bullet, v1 cap is equal to, so this one is the initial, this one is the final velocity of bullets. You can write it in full. Then our v2, not v1 here, so v2 is equal to initial velocity of pendulum, v2 cap is the final velocity of pendulum. So we have said v1, so the momentum, the summation of the initial momentum is equal to the summation of the final momentum. So if we are going to say m1, or the mass of the bullet times v1 plus mass of the pendulum times v2 should be equal to the mass of the bullets. They are not, the bullets went through, so there will be mass of the bullets times the velocity 1 cap plus the mass of the pendulum times the velocity of the pendulum, like that. So we are going to have mass of the bullet is, so 15 just divide by 1000 grams multiplied by the 1 kg chain link. So this will give you 0.015 kg. So you are going to have 0.015 kg times what is our velocity number 1. So our velocity number 1 is equal to the bullet, which is 600 meters per second, according to what we have been told, that it was traveling at 600 meters per second. Then we have plus the mass of the pendulum. We are told that it's 3 kg times, at first it was at rest, so it's 0 meters per second, should be equal to the mass of the bullet. It is the same. The mass of the bullet is the same. So we have 0.015 times the velocity it starts to move with, which we don't know. plus the mass of the pendulum, which is a 3 kg, times the velocity with which it moved after being strike with a bullet we don't know. So to simplify now, let's multiply 0.15 times 600. This gives us 9. So we are going to say 9 plus our 3 times 0 is just 0. So we have 9 should be equal to 0.015 v1 prime plus our 3 v2 prime, like that. So with that done, we are going to now refer to the conservation of energy. So we can say by conservation of energy, the summation of the potential energy that is gained by the pendulum. The pendulum was the one that gains the kinetic energy because it has moved up, but this time it's alone without the bullet. So the potential energy of the pendulum should be equal to the summation of the kinetic energy of the pendulum. If they were together, we could have had the composite mass. So in this case, it will be the mass of the pendulum times the gravity times height, because we know potential energy is equal to mgh. Mass of the pendulum should be equal to, we have half, the kinetic energy is equal to half mv squared. Now in this case, this is the mass of the pendulum times the velocity of the pendulum squared. So in this case, we divide by our mp, so that we have our gh should be equal to half v squared, which is this velocity is the velocity of the pendulum. So 2 by this, we are going to have 2 by this, it will be 2gh should be equal to v 2 cap squared, so that we have the square root, this and this goes, so we have the square root of our 2gh is equal to v2 cap. Replacing, we have the square root of 2 times 9.8 times the height, 10 centimeters. To convert it to meters, divide by 100 centimeters, then multiply by 1 meter. So if you want, you can be doing 10 centimeters is equal to 1 meter, 10 centimeters. You can be doing the usual conversion. If you want 100 centimeters is equal to 1 meter, how about 10 centimeters? And then you will say x, but still it's going to give you the same thing, which will give you 0.1 meters. Then we are going to put 0.1 meters should be equal to v2 prime. So multiplying, we have 2 times our 9.8, then times our 0.1. This will give us 1.96 should be equal to v2 prime. The square root of this value gives us 1.4 meters. So this is our v2 cap. Getting this equation, we are going to say, so getting this equation, we are going to say, replacing, so we have our 9 should be equal to 0.015 v1 prime, then we have plus our 3 v2 is 1.4 meters. So we are going to have 9 should be equal to 0.015 v1 prime plus our 3 times our 1.4. We are going to have a value of 4.2. We take it this side, it will be 9 minus 4.2, which will be equal to 0.015 v1 prime, which gives us a 9 minus 4.2 This gives us a value of 4.8. 4.8. Yeah. So we have 4.8 should be equal to 0.015 V1 prime. Dividing 0.015. By logic, we expect it to be less than its original speed. So 4.8 divided by 0.015, this gives us 320 meters per second. So this is our speed of the bullet after. At first it was moving at 600. At first it was moving at 600 meters per second. After that, since it passed through this, it lost some kinetic energy. It began to move with 320 meters per second. Thank you very much for watching. Hope you would like, subscribe, and share for more. See you in the next tutorial.